the size of the particle is higher than that of true solution and it is found to be heterogeneous. Examples for a colloid solutions are milk, ink, starch in water, butter, fog, mist, smoke, etc. And examples for suspension are chalk and water mixture, calcium hydroxide in water, this is used for whitewashing, and bleaching powder in water. Semi-transparent, whereas suspension is opaque, not transparent at all. Third property, nature. A true solution is homogeneous. The composition of the mixture is same throughout the solution. Whereas in a colloid, it is heterogeneous. Composition is not the same throughout the mixture and the suspension also heterogeneous. Fourth property, filterability. A true solution passes through ordinary filter paper and also a semi-permeable membrane, whereas the colloid pass through the ordinary filter paper and do not pass through semi-permeable membrane, and suspension do not pass through ordinary filter paper and also semi-permeable membrane. Then setting of particles. In a true solutions, particles do not settle down, so it is called stable. Whereas in a colloid, the particle do not settle down and it is also stable but can be made to settle by centrifugation. Centrifugation is a technique used to separate smaller particles. In this method, the mixture is rotated at a very high speed and the heavier particles are forced to settle down at the bottom. And then in suspension, the particles settle down on standing and it is unstable. Sixth property, Tyndall effect. In a true solution does not show Tyndall effect and do not scatter light, whereas the colloidal solution scatter light and show Tyndall effect. And in a suspension, Tyndall effect may be observed, it is not necessary. Then nature of particles. Ions or molecules are present in a true solution. In a colloid, single macromolecule or aggregate of many atoms or ions as well as molecules. Single macromolecules are observed in protein and in some polymers. Then aggregates of atoms, the group of atoms, many atoms combined together, ions or aggregates of molecules are seen in colloids. Whereas in suspension, only aggregates of atoms or molecules. And then the eighth property, visibility. Seventh property, nature of particles. Ions or molecules are present in a true solution. In a colloid, single macromolecule or aggregates of many atoms, ions or molecules are present. Single macromolecules are present in some polymers and also in protein. And aggregates of groups of many atoms, ions or molecules can be seen in colloid. Whereas in a suspension, only the aggregates of atoms, group of atoms or molecules are present. And the eighth property, visibility. In a true solution, the particles are not visible under a microscope. Colloidal particles are also invisible but can be seen under an ultra microscope. And in the case of suspension, you know that particles are visible to naked depending on the states of dispersed phase and dispersion medium. 8 different types of colloids are possible. Here the first 4 are salts, solid salts, salts, solid aerosol and aerosol. In all these cases, dispersed phase and dispersion medium are different. In solid salt, dispersed phase is solid and dispersion medium is also solid. So they are solid salts. For example, colored gemstone and milky glass. In salts, dispersed phase is solid and dispersion medium is liquid. Examples: starch, white of egg, blood, gelatin and latex. In solid aerosol, you might have noticed smoke and dust. Here the carbon particles are distributed in air. So dispersed phase is solid and dispersion medium is gas. That is solid aerosol. And in aerosol, dispersed phase is liquid and dispersion medium is gas. Examples: fog and mist and sprays also. Now let us see what is a gel. In the case of gel, dispersed phase is liquid and dispersion medium is solid. Example: all jellies, cheese, butter, curd and shoe polish. In emulsion, both dispersed phase and dispersion medium are liquid. Examples: milk, face cream and cod liver oil. And in solid form, dispersed phase is a gas and dispersion medium is solid. Example: rubber. And in form, dispersed phase is a gas and dispersion medium is a liquid. Example: soap, lather and shaving cream. Now let us discuss the properties of colloids. The 4 properties of colloids are Brownian movement, Tyndall effect, electrophoresis and coagulation. Let us see the first one, Brownian movement. The colloidal particles are always in a state of motion. They hit each other and bounce back. They always move in an irregular way called zigzag way. Because of this collision, the particles always in a state of motion. This movement is called Brownian movement. The second property is Tyndall effect. You know that when a beam of sunlight enters a dark room through a small hole from the window, the path of the light becomes visible and dust particles present in air can be seen in the ray of light. Similarly, when a beam of light is passed through a colloid, the path of the light will be visible due to scattering of beam of light by the colloidal particles. This special effect is called Tyndall effect. the path of the light is visible due to scattering of light called Tyndall effect. Now let us see the third property, electrophoresis. You know that the colloidal particles possess a charge, either positive charge or negative charge. This positive charge is attracted towards the oppositely charged negative charge electrode, and the negatively charged particle is attracted towards the positively charged electrode under the influence of an electric field. When an electric field is applied, the positively charged colloidal particle move towards the negatively charged electrode, and negatively charged colloidal particles move towards the positively charged electrode. This movement of colloidal particles is called electrophoresis. Then the fourth property, coagulation. The colloidal particles can be separated by addition of a small amount of electrolyte. This process, in which colloidal particles are separated by addition of a small amount of electrolyte, is called coagulation. We know that a bleeding from a cut can be stopped by applying alum or ferric chloride. Usually electrolytes like sodium chloride and barium chloride and alum are used for coagulation.